All right, guys, we are on our first unit, and it's all about algebra basics. So it's things that you need to know in order to be successful later in the year. The first and most important thing we start with is the real number system, because we got to know what we're dealing with. Now, when I say the real number system, it implies that, well, if you have a real number system, is there a fake one? And the answer is kinda. We do have an imaginary number system, but you're not going to deal with that until Algebra 2. So make sure as you go through Algebra 1, we are only working with the real number system. All of Algebra 1 is real number system. So what is a real number? A real number is anything that we are dealing with in algebra. And we use the abbreviation R to classify a real number. So it could be like pi, it could be 2.1467, where 6/7's repeating. It could be -3, it could be 12. It's any number that we deal with in algebra. From there, it branches off. If you have a real number, then it branches into an irrational number or to a rational number. Irrational numbers are those numbers that are never ending, there's no repeating pattern. Those are like your mumbo jumbo ones. And we abbreviate it with the letter I. It includes pi, that's the one that is most popular. But it's also any number that is not a perfect square. So for instance, if you have the square of 48, there's no perfect square, so square root of 48 can be an irrational number. It can be a number like 2.1276 ... that goes on forever and ever. That is an irrational number. So everything's going to be a real number system. So on a quiz, on homework, on anything, you always want to use the classification of R because that's a real number. Then we've talked about irrational numbers. A rational number is anything that can be put in the form A over B, where B is not equal to 0. So if you can remember this concept that it can be put in a fraction, your world is going to be so much easier. So let's take a look at that. First, this letter is gone. So what do we use instead? Since R is already taken up, we use Q. And that is worldwide. That's not just something that I use, that's everywhere. So make sure you understand that rational numbers are Q. So like I said, it can be put in the form A over B. So if I look at 2 2/3, is that a rational number? Well, sure. I can popcorn 2 2/3, and I can do 3 times 2 plus 2 and get 8 over 3. Bam, it fits the pattern A over B. So 2 2/3 is a rational number. What about 0.45? Well, sure, I can turn this into a fraction, 45 hundredths. And 45 hundredths fits the form A over B. So 0.45 is a rational number. What about the number 3? Can I put that in A over B form? Sure. It's a whole number, so I just put it over 1. And now it fits the form A over B. So 3 is a rational number. So notice you can have fractions, decimals, and whole numbers. You can also have something that looks like this, 0.66 repeating. Can I turn that into a fraction? Yes, and if you remember from your fraction lessons last year, this would be 66 over 99. Fits the form A over B. So 0.66 repeating is a rational number. Now, once you get into rational numbers, you have other categories. You have an integer. So all rational numbers are real numbers. All integers are rational numbers. So notice this sign. If something's a natural number down here, it's also a whole number, it's also an integer, it's also rational, and it's also real. So integers, we're going to classify with the letter Z. That's integers. An integer is any whole number that's negative or positive. So when you think of integers, I want you to think of the number line that you saw in kindergarten or in elementary school. All the teachers had it, negative numbers through positive numbers. And they're all counting numbers. They're easy to count. Whole numbers. Whole numbers, we're going to use H for a whole number. And whole number is any positive integer, including the number 0. So it's 0, 1, 2, 3, 4, and so on. And again, it's a counting number. It's a whole number. Natural numbers, if you look down below, hang on, let me scroll up. Natural numbers, everything's shifted there. Sorry about that. You use n for a natural number, and a natural number is any number positive integer 1 and above. So natural numbers and whole numbers are very, very similar. The only difference is natural number does not include 0. So if you look at this, a natural number, it is a whole number, it is an integer, it is rational, and it is real. Okay? So that is the real number system. Now we're going to do a few examples together. So if you look down at the bottom of your notes page, we're going to name each set to which these numbers belong. And what I also want you to do is if you can put it in the form A over B, I want you to put it in that form. So number 1, does it fit the form A over B? Sure, I can turn it into 30 over 1. So we know that it's real. All of these are going to be real. We know it's real. We know it's rational. We know that it is an integer. We know that it is a whole number, and we know that it is a natural number. Does everybody see how I'm getting that? It's all of them. All right. We're going to skip around here. I'm going to do the first column and the last column. So number 4, square root of 21. It's not a perfect square. So if it's not a perfect square, we do know that it's real, and we do know that it is irrational. I can't put it in the form A over B. Number 7, it's already in the form A over B, but we always want to simplify, and so really this comes to 2. So think of the number 2. We know that 2 is real, it's rational, it's a whole number, it's an integer, it's a whole number, and it's a natural number. It fits all of the categories. If you look at number 10, I can simplify this. Square root of 144 is 12 over negative 3, so it's in the form A over B, but if I simplify it even further, I get the number of negative 4. So it belongs to the real number system because that's what we're working with. It is rational, it fits the form A over B, and it is a whole number. Excuse me, why did I say whole number? And it is an integer. It is an integer. And it stops there because whole numbers and natural numbers have to be positive. This isn't, so it's going to stop. If you look over on this side of the page, number 3, it does fit the form A over B. I can turn it into 35 plus 4 is 39 over 7, fits the form of a rational number. So I know that it's real because that's what we're working with, and I know that it's rational. I stop there because it's not a counting number, so it's just these 2 categories. Number 6, I can simplify to negative 3. And again, I can put it negative 3 over 1. We know we're working with the real number system. We know it's rational because it fits the form A over B. I know that it is an integer because it's negative and positive, but it is not a whole number and it is not natural because it is negative. Number 9, it does fit the form A over B because this is 5 3/9, which then in turn could do 9 times 5 is 45, plus 3 is 48 over 9. So it fits the form A over B. We know that it's real, and we know that it's rational. It is not a counting number, so it stops. We're done. And then if you look down here on number 12, this is kind of a tricky one. Remember your division rule. Anything divided by itself is 1. Anything. X divided by X is 1. 5 divided by 5 is 1. A million divided by a million is 1. So if you have the square root of 17 divided by the square root of 17, anything divided by itself is 1. So it simplifies to 1, which I can put as 1 over 1. So we know it's real. We know it's rational. We know that it is an integer. And because it's positive, 1, it's whole and it's natural. So that's your first video on the real number system.